Greetings to everyone from Team 5. Our project for the industry-driven elective Artificial Intelligence and Machine Learning is stock price prediction. Our team members include me, Pradyot P, Ayush Ravi Patil, Aprameya L, Swastik Nettar, Ishan Bagaria, Adarsha KK. Our mentors were Ashwini M, Rajat Duggal, and Bhagyashree. Going into the problem statement which we have chosen, which is stock price prediction, our challenge is to accurately predict the future closing value of a given stock across a given period of time in the future. Getting the optimal solution is the key, and for this, we are not just relying on the machine learning algorithm used. As we would like to predict the stock prices correctly, we need to decide when to buy and sell to make a profit, and this is where we need to think about various factors, and hence we have created time series modeling to predict the prices more accurately. Along with that, we have three different approaches to the solution. One is LSTM RNN model, another one is to calculate the intrinsic value, and sentiment analysis. The LSTM RNN model, which is long short term model, it predicts the value based on our training to the model. Intrinsic value takes into factor the current price, the profit, and the future movements which can occur with the stock. Sentiment analysis looks at a particular platform, say Twitter, and analyzes the sentiments of that particular stock expressed by users around it. Our code can be found on GitHub. The link is given over here. Coming to the ML model which we have used. LSTMs are a type of RNN which remember information over long period of time. The information has various factors which come to it, and we have the input gate, control gate with the forget gate, and the output gate as well. So coming to our LSTM model, so this is the file, and as you can see, we've structured the code over here on GitHub. So coming towards how we have chosen the data set. So taking a data set which is existing will be tough because of our use case. So we are actually retrieving the data set till 2022 of TSLA stock from 2015 using a module called Y Finance. So as you can see, this is the stock price, and as you can see, the movement is very irregular. Since the stock has rapidly increased in 2020 when Tesla came into the global picture about the electric vehicles, and the trend increased. So predicting this is a major task, and we'll show how we have done this using our LSTM model. So as you can see, we've created the tesla.csv file using Y Finance, and we have normalized the data. Basically, we don't need all these columns, so we have removed what all we do not need, and based on the same, now we have the open, close, and volume which we need. So after that, we have created our model, and these were our initial approaches which gave us solutions, but it did not quite give us the solution we required. So going to the actual solution which we got. So yeah, here as you can see, we are reading the file to our data frame, and this is our final approach with LSTM, which worked and predicted the stock prices properly. So this is our data frame with what we need, and this is the actual data. So now we are dividing the data into training data and test data, and we are taking our around 65% of it for training size, because we have this irregular pattern. We need this data as well to be accounted in the training data. So now as we have created the data frame we need, we are also going to shape it to our the input we need for the LSTM model. And here we have added the LSTM model with the input shape and return sequences, and we're going to check about the efficiency and the error with the root mean square error as well, which I'll show in a bit. So we are using 100 epochs, which is basically we are testing it 100 times to check the efficiency of the model. So now you can see that right now in our initial approach, our mean square error, it's pretty high. But we'll soon train the model enough so that this reduces considerably. So right now, this is the difference between the predicted and the actual price. So moving forward, we are going to demonstrate the prediction for the next 10 days. And here we're going to show how our output is actually matching the actual trend which occurred. So these are the actual prices, and moving forward, so here we have plotted the graphs, and here when we look into our approach, we are also going to see the open, high, low, close average. So as you can see, it is this way. And now we're adding the model again and training it based on the data which we have reshaped so that we reduce the RMSE value which we had got previously. So as you can see, the model has been trained and compiled, and now we are predicting. So yeah, now we have the RMSE value which is considerably less, and here you can see that the green part, which is really small, and the training set, as you can see, actually this is the original data set which has been divided into training and test. And as you can see, the graph overlaps completely with the original data set. So what does this mean? This means our model is predicting accurately, and the blue line over here signifies our prediction. So we also tried out different models, but this is the best output we got, and this is the output we got from the LSTM model. Right now we are going to look into the sentiment analysis part of this project. Over to Swastik.
Thank you, Pradyut. Well, we know that sentiment analysis is nothing but identifying the emotional tone that is behind the body of the text. That means whatever text a person writes will understand what his emotion is. And in sentiment analysis, we consider polarity and subjectivity as two factors. Polarity is nothing but what is the strength of the opinion or the text that a person has written, whereas the subjectivity refers to degree to which a person is personally involved with that object or the text that he is referring to. Okay, in the model that we have done, first we import all the required libraries, and then we have taken an example as for Tesla, and then we use the SN Twitter module to get all the tweets from the Twitter for the limit of the the number of tweets that we have taken is just 2000, and then we have then added that to a data frame, and then this is the output of that data frame. Afterwards, we have cleaned the tweets that we have got. We have removed all the hyperlinks, the et functions and the hash values, and even retweets and all. And then we are updating the data frame. After that, we are calculating the subjectivity and polarity. Yeah, and then what output we get is for a particular tweet, what is the subjectivity and polarity, and at the same time we even do the analysis part of that. If polarity is 0, the analysis will tell that it is neutral, and if it is more than 0, it is positive, and if it is less than 0, it is negative. After that, we are printing all the positive tweets, and after printing all these positive tweets, we go on to print the negative tweets. Now here we have printed the negative tweets. Yeah, and after that we have plotted the dot graph for the tweets and the corresponding polarity and subjectivity. Here we can see that many number of tweets are lying in the value 0.00, which indicates that many tweets are in a neutral favor, and the next what comes is the positive, and the last one is negative. This is also shown through the percentage of positive tweets that we got and the negative tweets. And at last we have printed the bar graph of the tweets present in each neutral, positive and negative side. That's it.
As you can see, the sentiment analysis part predicted the emotions which go into investors around a particular stock, which was Tesla over here. Now we will check the intrinsic value part. and basically how that value affects how the stock prices vary. Over to Ayush.
Hi, thank you, Pradyut. So now we'll be looking at intrinsic value. This model is used by some of the world's biggest investors like Warren Buffett. So essentially, intrinsic value means we are taking a stock and seeing what it's actually worth. Like if the company sells today due to some reason, how much money will be dispersed among each shareholder, and this along with growth can give the intrinsic value. So I've just loaded the data. This is for Apple stock. Uh, we have revenue, gross margin, income, and margin, and this is available in the CSV file in the root folder. Then we start just deciphering some common financial data like total number of shares, and we are reading some historical shares. So company can choose to increase number of shares or decrease. So let's go a bit below. Then I'll show you how we work further. Then we just correcting the data type, and we are taking some common financial terms like earnings per share, which is essentially a very widely used financial term. Then dividend rate is basically how much dividend we are getting. Stocks pay dividends as profits for holding the stock. All of these can be accessed through the CSV folder and publicly available. Can we go below? Then we have dividend yield. Essentially, dividend yield is another term which tells us how much dividend we are getting versus what the stock is worth. We have used another term, debt equity ratios. All these ratios help us arrive at a very close value. Then we use the book value. This is what I was talking about. This is if the company is sold today, how much money will be dispersed among the shareholders. So that is $21 as per the value. So on this, we apply a return on equity and growth. This will help us get the intrinsic value. Then if we scroll down below, we can access even more terms. All these terms are essentially being added to improve the accuracy of the price. Then we are just transposing the data, which is essentially switching columns and rows. Then we can see the exact metrics. We are just cleaning it and renaming rows and just cleaning up the data for better visualization. Now let's move to get the actual intrinsic value. So we have imported the data. And this is intrinsic value. We are estimating the future dividends. So we just have the estimated future book values, and we're just combining all of this data to get a graph. And this graph, as you can see, gives us Apple's dividend, which is increasing in a very drastic manner. Then we find the book value, and using linear regression, which is seeing how one variable affects another variable, we are finding that out. If we just go down below, we can arrive at the intrinsic value. So this is how it works. So why we use this thing? Intrinsic value, as I mentioned, is used by some of the world's biggest investors like Warren Buffett, Guy Spear. They have used this for many, many years. So this is one tested method of finding the right value of the stock. I would like to conclude by saying that some of the biggest banks and trading firms have a lot of data, but as common people, we don't have access to a lot of data. And even if we have the data, we are not able to analyze it well. Through this project, we want to help all the common people access data, and essentially everyone has data. It's about who analyzes it better. Now I would like to hand it over to Pradyoti.
Thank you for that, Ayush. As you can see, we had 3 different approaches towards the problem, and basically we've got results in all the 3 approaches. And based on this, the future enhancement which we can do is to combine these 3 models so that we get more accurate results, and it helps stock market investors much better. The reason behind choosing this project was simple. We needed a problem statement which is actually a problem right now. If you look at the machine learning projects which are done on a trending basis, which is a house prediction or face mask detection, hand detection, they have already been done and the outputs are tremendously good. So there's no point in doing redundant stuff, and that is why we've chosen this project through which we aim to make a difference. And I would like to thank Nokia and the Department of ISC of NI Mysuru for giving us this opportunity. Thank you.